The images you've just seen were photographed by a film camera. They'll be used for the titles of all the television programs in this course. And since this is a computing course, it's appropriate that the camera movements were controlled by a computer. We'll be showing you some more of that camera later in the program. In fact, we'll be showing you a number of different computer systems and a wide variety of applications. But despite the variety, the underlying structure of all the computer systems we'll be showing you is exactly the same. And it's the same structure you'll find in the home computer that you'll be using for the practical work in this course. This is a typical machine. It's an Amstrad. It's got a keyboard, a screen, and a box which contains the works. The keyboard is used for what we call input, to allow you to input information into the computer. The screen is used for output, to allow the computer to pass information out to you so that you can read it. Diagrammatically, the system looks like this. This box contains the works of the computer. It's linked to an input, such as a keyboard, and an output, such as a screen. We divide the works of the computer into two parts, the CPU and the memory. The CPU is the computer's processing unit, and the memory is where the computer stores its data. But the memory has a limited size, and it can only be used when the computer's switched on. So there's also a system of secondary storage for long-term use. This computer uses floppy disks for secondary storage. You'll already have seen some of these because we use them for the software for the course. When you put one of these disks into the disk drive, information can be copied from the disk into the computer's memory. The disk I've just inserted contains the P system. And when the copying is complete, the standard prompts will appear at the top of the screen. You can also copy information from the memory back onto the floppy disk. So that's one of the microcomputers we can use. But there are several other kinds, and although there are slight variations between them, the basic underlying structure is exactly the same. This computer is an IBM PC XT. And as you can see, it'll run the P system in exactly the same way as the other machine. However, you might have noticed that I didn't need to insert a floppy disk. This machine has a hard disk that's permanently installed inside this box. The hard disk has a much greater capacity than the floppy disk, and that's why you don't need to interchange the hard disk. Also, it's more rigid. Therefore, it can spin faster, and the information can be copied from the disk into the memory more quickly. In fact, this machine has a floppy disk drive as well as the hard disk. Floppy disks can be used to transfer software from one machine to another. They can also be used for backup. That's making copies of the software in case something happens to the originals, and you should always do this. So this computer has 2 units of secondary storage, rather than 1. It also has 2 output devices, because as well as the screen, we've connected a printer to it. This is particularly useful if you want to look through the output at leisure. For instance, when you're trying to find a mistake or a bug in a program. Now I have one more microcomputer here. It's called a Macintosh. And once again, there is a keyboard for input and a screen for output. But this computer has another input device. It's called a mouse, and you use it in conjunction with the screen display. The screen shows several small pictures representing a menu of different things that you can do. The pictures are called icons, and you point to the icon you want with an arrow. You move the arrow by sliding the mouse along your disk, like this. When the arrow is pointing to the correct icon, you press the button on the mouse, and that tells the computer which action to carry out. For example, the dustbin means delete something, throw it away. For many types of computing activity, using a mouse is more convenient than typing in information at the keyboard. So these three microcomputers all have a very similar structure, although their detailed construction might be quite different. And this structure is just as relevant for much larger computers and for computers doing quite different tasks. This is one of the computer rooms at the Open University. It's where a lot of the university's administrative work is handled. This room contains a mainframe computer. That's a large computer system capable of handling many different sorts of programs. Typically, a mainframe system comes in several large cabinets, containing the computer itself and what are called its peripherals. For instance, this cabinet contains one peripheral. It's a line printer. It gets the name because it prints a whole line of type at a time, rather than printing each character separately. Printers like these are physically large, and they work at a very high speed. They're also extremely noisy, even with the acoustic hood in place. But fast printers like these are essential, because mainframe computers can process so much work. Just outside the main computer room is the data control area. This is where the work for the computer is scheduled. Each of these terminals is connected to the mainframe, and they can be used for initiating programs. Many of the programs running on the system are called batch programs. Although the computer is being told now to run them, it doesn't do so straight away. Instead, the programs are run later in the day. The messages on the screen are acknowledgements from the computer that this will be done. On a diagram, the overall structure of this computer system is the same as the structure of the microcomputer we saw before. But of course the details are rather different. There are 14 terminals connected to the system. These are combined input and output devices. The computer uses both hardware and software to make sure that the input from a terminal keyboard corresponds to the output on the same terminal screen. So we might do better thinking of the terminals as separate units, each with an input and an output. And there's also a special input system for bulk data. One of the files handled by the system deals with processing of assignment scores. There are so many of these scores to be entered that a special data entry section is needed. There are terminals here too. These are specially designed so that the fast entry of data is much easier. The keyboard's smaller than usual, and most of the keying is done with one hand. But the data entered here doesn't go straight into the mainframe computer. Instead, it goes to the input system. You can think of the input system as a separate computer in its own right, with secondary storage on both disk and tape. When the data is entered at a keyboard, it's immediately stored on disk. This is called a key-to-disk system. Later in the day, the data is transferred from disk to tape. And then the tape is physically moved from this special computer to the main system. First, the tape containing the student assignment scores has to be mounted. That's a job carried out by operators in the computer room. There are 9 tape drives in here, all connected to the main computer. This drive is waiting for the tape with the assignment scores. Deciding which tape drive should be used for each program is one of the computer's housekeeping tasks. The communication with the operators takes place at a central console. Once the operator types in that the tape has been loaded, the computer checks that it's the correct one. and then starts its processing of the data. Our next application is very different indeed. It's the French Teletel system, where you plug a computer terminal called a Minitel into your telephone.
This Minitel is the M1, the basic one, which is very successful with its printing machine. This one is the color one from La Radio Technique. You've got a Minitel with a microcomputer you can have at home to work your own service. This is the dialogue Minitel for deaf people. And this one is the brand new one from Matra.
Est-ce que vous savez comment fonctionne un Minitel?
Non, mais j'ai une amie qui va m'expliquer.
Vous voulez tout de même que je vous recherche votre numéro sur Minitel?
D'accord.
The French public can get their Minitels by taking a form down to the local telephone agency. The Minitel itself is on free loan, and it's offered first to frequent telephone users.
C'est bien le 43 20 03 46.
C'est bien ça.
Using the electronic telephone directory is free. However, most of the other services have a charge.
Alors, vas-y. Écoute, c'est très simple. On va faire le 11. C'est l'annuaire.
Every Minitel has a built-in modem, and it plugs directly into the phone socket. The phone itself, which can still be used normally, is plugged into the back of the Minitel.
Paris.
You can do many more things with the electronic directory than you can with a printed one. For instance, here's a list of child doctors in the Paris 14 district. The computer has done the sorting automatically. But there isn't just one computer in the system. In the Teletel system, each information provider has a computer with connections for several remote terminals. These connections are called ports. But the ports are only linked to terminals when a subscriber dials up the connection. The link between the terminal and the computer is made by the telephone system. And these links are changing all the time as subscribers connect themselves to different computers. One of the uses envisaged for the Teletel system is direct selling to subscribers' homes. Even some of the more traditional French businesses, like winemaking, are joining in. Although an individual chateau might not have its own computer, it can join a service specially set up to give information about wine, l'Abbé des Vins. The first page gives a choice of options. One of them is choose wine by region. But l'Abbé des Vins is only one of the services available on Teletel. Radio Fun is a popular music radio station. It has games with prizes for listeners who predict the top hit record. It also allows listeners to vote for their choice of music. Another service is Antigel. This is a message service. There are public rooms, or salons, and users can enter a room with a code name. There are usually several conversations going on at any one time, and anyone can join in the moment they find a free space. The Teletel system uses standard input and output units, but some applications require special purpose equipment. Let's return to the United Kingdom and go shopping in the traditional manner. This is one of the House of Fraser stores in London.
It's quite a strong fragrance, isn't it?
Yes, it's the eau de parfum strength as opposed to an eau de toilette, so you will find it stronger. We have two bottle sizes, that's 40 mils at £25 and 75 mils at £38.
I think I'll take the £25 one, please.
Right, that's lovely. How would you like to pay?
Account?
That's fine. May I have your card, please?
Despite appearances, the electronic till being used for this sale is actually a computer terminal. It's an example of a special purpose input device. We'll find the reason for its use a few miles away. Here in the House of Fraser head office, the information from those special terminals can be used to monitor the progress of today's business. Chris Surridge, Business Systems Manager, took us into the Chief Executive's office.
This is our online sales system that enables us to look at sales throughout the company as they're actually happening. We can look at sales by department or by store. And here we have the Midlands division with the stores in their areas. The Manchester area, the Hull area, the Birmingham area, and that is the total sales from those stores in that division up to the minute. And if I now wanted to look at a particular category of merchandise, I would simply enter that category onto the screen and have a look at the sales. Here we're looking at the housewares and pastimes category. If I now wanted to look in greater depth in that category at a particular department, I would simply enter the department number. And let's take, for argument's sake, the cosmetic department. And we see immediately, this is precisely the information our chief executive needs to enable him to see that the business is performing up to expectation.
The House of Fraser has a central computer system. This has links to terminals, like the one in the Chief Executive's office. The information about sales comes from those special purpose cash tills, which also act as computer terminals. And because there are so many of those terminals, there's an additional family of computers which package the data before sending it to the main system. These are called front-end computers. Our next application also uses special purpose hardware, but of a rather different kind. The new terminal building at Gatwick Airport was designed by the YRM Partnership, a firm of architects. As well as traditional tools of the trade, this company used the techniques of computer-aided design.
We were the first architectural firm to buy an intergraph system, certainly in Europe. So to some extent, it was a very sort of experimental step to take. It's a turnkey system based on a standard digital processor, the VAX 11750. The processor drives 8 workstations. Through the terminals, we produce full-size models of buildings. We go into that model and select different parts of the building at different scales with different levels of information on. And that we do through an electrostatic plotter. We have hard copy units, which mean that we can take instantly sketch images from one of the screens of the terminals. And we have a certain word processing capability on the system as well.
One of the input devices on this system is a special menu tablet, containing basic elements like circles, lines, and curves. These are selected by a mouse, which is also used to locate the elements on the screen. To see what can be done with this system, suppose that a large office space has to be split in two. The high-resolution graphics screen shows the existing layout. Individual components, like the partition walls, can be copied and moved from one location to another. The software provides a grid on the display, and the components snap onto the grid when they're positioned. To make a change, such as inserting a new door in the partition, the component is called up by identifying its code number. Then it's located in position using the mouse. Using a computer-aided design system like this means that the architects can work on refining their design, yet still give accurate information to the various contractors working on the building. For a large and complicated construction, like this new terminal building at Gatwick Airport, the flexibility provided by the computer system has proved invaluable. And a similar sort of flexibility was needed when we produced the title sequence for this program, although the equipment we used was rather different. The camera we used to film the titles was bolted to a massive steel arm, with electronically controlled motors to adjust its position. There was also a video monitor, so that the camera's view could be matched to the designer's rough sketches.
Okay, we've got 26 frames here, so it'd be nice if we could swing around quite dramatically around to the other side, out of the shadow.
Okay.
It's a little bit tighter as we swing around. Why don't we swing around the object?
All right. Okay, how about that framing there?
That's nice.
Yeah. Okay, I'll put that in.
And we need to do that in 26 frames.
For an animation, the camera must move through a range of positions.
It'd be nice to lose some of these objects in the background and keep that highlight.
Instead of driving the motors directly, the control buttons were inputs to a computer.
This is close. How close do you want to get to
A
this?
little bit tight.
The motors were the computer's outputs.
And bring the camera around to the right.
Okay.
Key positions on the move could be established by hand.
And then swing round to the back of it.
Yes, losing some of the background objects.
How about that?
Yeah.
And I'll just enter them.
Once this was done, the computer would drive the camera smoothly from one position to another. So that's yet another example of a computer system which uses special purpose hardware to carry out a particular task. But whether the equipment is specialized or for general use, it always has the same structure. There are inputs and outputs, there's the processing unit with its memory, and there's secondary storage. And this basic structure is common to all the different computers that we're going to meet in this course.